Good morning, students. So in the last class we discussed that is preparation, formulation of double bond. Okay. So in the double bond we studied how the carbon monoxide, sorry, dioxide will form and how that oxygen atom will form. Okay. So next one is the formation of triple bond. As I told you, there are three types of bonds are there. Formulation of triple bond. Okay, three types of bonds are there: single bond, double bond, triple bond. In the covalent bonds, we studied single bond, double bond, and now it is triple bond. Okay, so I'll take the example here: formation of nitrogen. Okay, so the main thing in the Lewis concept is what to make the formation of the bond after the bonds, no matter whether it is a single bond, double bond, or triple bond. Okay, so after the formation of the bond, they should satisfy 8 electrons in the outermost shell, including bonded electrons. I write here. So one nitrogen, its atomic number is 7, configuration is 1s2, 2s2, 2p5. 1s2, 2s2, 2p3. So this is complete shell, one means K shell, this is L shell. Means this one is the valence shell. As I told you, the one which is having greater n value are the valence shell. Here S and P both are having the n value here 2. Means this is the last shell. Means this is the nucleus of the nitrogen. This is 1s subshell. This is 2s 2p subshell. Both. So the last shell is what? 2s 2p. If next another shell is there, valence shell 3s 3p 3d. So another one. Similarly 4s 4p 4d 4f. Okay, so the last shell, or I will say the one which is with a greater number of n value is the valence shell. Understood? So in that, so 2s2, 2p3 is the valence shell. So total number of valence electrons are 5 here. On one nitrogen atom, 5. So listen, I'll write the nitrogen atom here first. So assume this is step 1. Okay, so I represent 3 electrons here. So this is one nitrogen. What are these 5 dots means? Those are 5 valence electrons in the outermost shell. That is represented in dot. So first what happened in step 1? So listen, here alone nitrogen has 5 electrons, here alone nitrogen has 5 electrons. So we need to make a bond to attain 8 electron system. So how? So one electron from this nitrogen, another electron from this nitrogen form a bond here. One electron from this, another electron from this forms a bond here. Then this electron is also belongs to this nitrogen. This electron also belongs to this nitrogen. When they together form a bond. So then, including bonded electrons. So these 5 are the electrons of this nitrogen, and this is the bonded electron. We have to round up. So now count 1, 2, 3, 4, 5, 6 electrons are there in the outermost shell after bonding. For this nitrogen also 1, 2, 3, 4, 5, 6 electrons. So the next one is step 2. If after bonding there is no if it is not follows octet rule, even after bonding, if it is not follows 8 electron system, we need to bond again. Until 3 bonds we will form. Understood? Single bond, double bond, triple bond we will form. 4th bond is not there. Next is that. Of course, another one bond is there. Later I will say. I write this structure as it is. Okay. Now this is the exact structure. So now what happens? Same. Again, one electron from this nitrogen, another electron from this nitrogen together form double bond. So now what happens? Count the number of electrons. 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. So even double bond formation also, they couldn't satisfy 8 electron system. Here it is 6, 6, here it is 7, 7. Next we need to do another bond. Step 3, formation of the third bond. Like as it is structure. Okay, so now listen, one electron of this nitrogen, another electron of this nitrogen, again form bond here. Then now count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. It satisfies 8 electrons. Here also 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. 8 comma 8 it is. So one after formation of 3 bonds, they form a electron system. Therefore, the equivalent structure is n triple bond n here. Okay, so here how the triple bond formation takes place. So we need to do one bond. We need to check whether the 8 electron system is satisfied or not. Next, if it is not satisfied, we need to form another double bond. After double bond also, we need to check whether it is satisfied or not. If not satisfied, we need to form another bond. Okay, this is the steps. So this is one example. If I take HCl, second one, HCl, yeah, are you right easily? This is the structure. Okay, we don't know which electron it is, sorry, which bond is formed in between this hydrogen, carbon and nitrogen. So check here. Carbon, its valency is 4 and directly write the valency. Nitrogen, its valency is 5. Hydrogen, its valency is 1. So now these two electrons form bond here and these two electrons forms bond here. Now, so this is the bonded electron for hydrogen. This is the bonded electron for nitrogen. Okay, next, so including these two, we will write. So students, here of course, this hydrogen satisfies 2 electron system, that is satisfied. This carbon is having 6, nitrogen is also having 6. So in between these two, we need extra 2 electrons. Means the next bond is formed in between this. So this is what? Step 1. Next, step 2, if you take, I'll directly write here. So hydrogen, so carbon, so these are already bonded. One electron is here, nitrogen. So remember here students, one electron of this carbon, one electron of this nitrogen, again form bond here. So this one set, this is one set, including this is one. Here hydrogen is satisfied as 2, carbon 2, 4, 6, 7. Nitrogen 2, 4, 6, 7. Extra one, even though after formation of the double bond it is satisfying only 7 electron system. We need 8 electron system including bonded electrons. So then that is step 3 is formation of the next bond. So there is hydrogen, carbon, okay. So listen here, this electron of carbon, this electron of nitrogen again form a bond. So now this satisfies 8 electron system. Listen, it is 2, it is 2, 4, 6, 8 for carbon and 2, 4, 6, 8 for nitrogen. Now here hydrogen is there, number of bond is 1, carbon, here the number of bond is 1, 2, 3, N. This is the structure of HCl. ಓಕೆ ಸೊ ಇದನ್ನ ಯಾವ ತರ ಮಾಡಬೇಕು ನೀವು ಅಂದ್ರೆ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಕೌಂಟ್ ಮಾಡಬೇಕು ಹೌ ಇಲ್ಲಿಂದ ಎತ್ತಿದ್ರೆ ನೈಟ್ರೋಜನ್ ಇದೆ ನೈಟ್ರೋಜನ್ಗೆ ಟೋಟಲ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದು 5 ಅಲ್ವಾ ಸೊ ಈ 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಇಂಡಿವಿಜುವಲಿ ಬರ್ಕೋಬೇಕು ನಮ್ದು ಮೇನ್ ಥಿಂಗ್ ಏನು ಇವನ್ ಇಂಡಿವಿಜುವಲ್ ಆಗಾದ್ರೂ ಇರಲಿ ಆರ್ ಬೇರೆ ಜೊತೆ ಬಾಂಡೆಡ್ ಆದ್ರೂ ಇರಲಿ ಸೊ ಹೊರಗಡೆ ನಮಗೆ 8 ಎಲೆಕ್ಟ್ರಾನ್ ಇರಬೇಕು ಔಟರ್ ಮೋಷನ್ ಅಲ್ಲಿ 8 ಎಲೆಕ್ಟ್ರಾನ್ ಇರಬೇಕು either by bonding or individually. So next ಇಲ್ಲಿ ನಾವು ಕೌಂಟ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಒಂದು ಬಾಂಡ್ ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತೀವಿ because we are studying bond formation. Okay, so ಒಂದು ಬಾಂಡ್ ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಆಗುತ್ತೆ ಅಂತ ಕೌಂಟ್ ಮಾಡಬೇಕು ಅದನ್ನ ಯಾವ ತರ ಕೌಂಟ್ ಮಾಡಬೇಕು the electron of the own atom and the bonded electron ಇದು ಬಾಂಡ್ ಈ ನೈಟ್ರೋಜನ್ ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇದು ಬಾಂಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈ ನೈಟ್ರೋಜನ್ ಗೆ ಇದು ಬಾಂಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದು ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಸೊ ರೌಂಡ್ ಅಪ್ ಮಾಡಿದಾಗ ಕೌಂಟ್ ಮಾಡಬೇಕು ಈ ಸರ್ಕಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ whether it is 8 that is satisfied no need to make further bond 8 ಇತ್ತು ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಬಾಂಡ್ ಇಲ್ಲಿ ನೋಡಿ 8 ಇದೆ ನಮಗೆ ನೆಕ್ಸ್ಟ್ ಬಾಂಡ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ ಇದು ಸ್ಟೇಬಲ್ ಇದೆ ಓಕೆನಾ ಸೊ ನಾವು ಎಲ್ಲಿಂದ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು ನಮಗೆ 8 ಎಲೆಕ್ಟ್ರಾನ್ ಸಿಸ್ಟಮ್ ಫಾರ್ ಬೋತ್ ದ ಆಟಮ್ ಎಲ್ಲ ಆಟಮ್ಗಳು 8 ಎಲೆಕ್ಟ್ರಾನ್ ಸಿಸ್ಟಮ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗೋದನ್ನ ನಾವು ಬಾಂಡ್ ಮಾಡ್ತಾನೆ ಇರಬೇಕು ಸೊ ಇಲ್ಲಿ 1 ಬಾಂಡ್ ಮಾಡಿದ್ರೆ 6 6 ಆಯ್ತು 2 ಬಾಂಡ್ ಫ್ರೇಮ್ ಮಾಡಿದಾಗ 7 7 ಆಯ್ತು ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಆದಾಗ 8 8 ಆಯ್ತು ಮೀನ್ಸ್ ಸೊ ಈ ಆಟಮ್ ಮಧ್ಯ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇದೆ ಅಂತ ಅರ್ಥ ಸೊ ಅಲ್ಲ ಅಷ್ಟೇ HCl ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ HCl ಮಾಲಿಕ್ಯೂಲ್ ಇದ್ರೆ ನಾವು ಇದು 2 ಮಾರ್ಕ್ಸ್ ಗೆ ಇದು ಮಾಡಬೇಕು write the list of structure of HCl molecule. Understood? Okay, this is another one. Formation of the triple bond. So next, another one important structure is there. Carbon monoxide. In that I clearly explain how the triple bond takes place. Okay, very important one. Carbon monoxide, third structure. Okay, so carbon ಗೆ ನೀವು electronic configuration ಬರ್ಕೊಂಡ್ರೆ valency 4 ಬರುತ್ತೆ oxygen ಗೆ 6 ಬರುತ್ತೆ so ಇಲ್ಲಿ ನೋಡಿ carbon 1 2 3 oxygen 2 3 4 5 6 so in step 1 water once this is the actual structures carbon with the 4 valency oxygen with the 6 valency so one electron of this carbon and one electron of this oxygen form bond here. Okay, so now if you round up, so this one 1 2 3 4 5 electron system, this one 1 2 3 4 5 6 7 electron system. For this oxygen, okay, we need only 1 electron. For this carbon, we need 3 electron. Okay, so later I will say. Next one is step 2, formation of a double bond. Now, 1, 2, 3, 4, 5, oxygen. Okay. So students, 1 electron of this carbon, okay, and 1 electron of this oxygen again form a bond here. Okay, next at that time what happens? This will take space. So here this is carbon with 2, 4, 6 electron system, oxygen with 2, 4, 6, 8 electron system. Means your oxygen is already satisfied. Okay, so here C single bond O forms. This is 5 electron, this is 7 electron. Here C double bond O forms. Here 6 electron, 8 electron. It is already satisfied. It cannot be able to form extra bond. But this carbon can form extra bond, can accept 2 electrons. So then what happens? At step 3. Okay, so if I take this, the step 3. So instead of bonding an electron, the 2 electrons of oxygen alone form bond here. Means third bond is completely filled by what? The 2 electrons of oxygen. Right? Okay, so electrons of carbon is not involved in bonding. Third bond is not formed by sharing of an carbon and an oxygen electron. It is formed by complete involvement of electrons of oxygen only. So now if you round up, then here 2, 4, 6, 8 electron system. This is 2, 4, 6, 8 electron system. So, but how do you represent here? It is not C triple bond O. This is wrong. This is how to write 1, 2, and the third one is the coordinate bond. Third one is the coordinate bond. Towards what? Towards carbon, because the electron is transferred towards this carbon and shared between carbon and oxygen. So that type of bond is called as coordinate bond. Means those 2 electrons where the triple bond is carbon, that is electrons of only 1 atom, but they are shared between 2 atoms. So this is how the carbon monoxide structure takes place. So the students, things to remember is only one. Remember, wherever carbon is there, it requires 4 bonds. Wherever oxygen, 2 bonds. Wherever nitrogen, 3 bonds. Hydrogen, 1 bond. Like that, you just remember the valency. Fluorine means halogens means 1 bond. Hydrogen is also 1 bond. Noble gases 0 bond. Carbon 4 bond. Boron 3 bond. Nitrogen 3 bond. Like that. Okay. So if you know the valency, then you can easily write the structures. So because they won't ask examination ಅಲ್ಲಿ ಅವರು ನಿಮಗೆ ಮಾಲಿಕ್ಯೂಲ್ ಯಾವ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಅಂತ ಕೇಳಲ್ಲ. ಲೈಕ್ ಈ ತರ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್. They directly ask write the Lewis-Strauss structure of HCl. ಅವಾಗ ನೀವು ಇದು ಫಾರ್ಮೇಷನ್ ಬರೆಯೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಈ ಸ್ಟ್ರಕ್ಚರ್ ನ ಬರೆದ್ರೆ ಸಾಕು. ಈ ತರ ಬರ್ಬಿಟ್ಟು H single bond C triple bond N ಅಂತ ಬರೆದ್ರೆ ನಿಮಗೆ 2 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ. They directly ask structure. So students, how to write the different structures in the Lewis-Strauss manner? I will. So listen. NH3, CH4, H2O. Okay. Next. NF3, etc. Okay. I'll write these 4 structures: nitrogen, ammonia, methane, water, and trichloroamine. So these structures are very good. Remember here NH3 means nitrogen 3 oxygens, 3 hydrogen bond ಆಗಿದೆ. ಅದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. So Lewis-Strauss structure ಅಲ್ಲಿ ಬರಿಬೇಕಂದ್ರೆ instead of writing bond, you need to represent them in a bonded manner. Okay, so dotted structure manner. So instead of writing one, You need to write like this. Okay, so this hydrogen is satisfied, this hydrogen is also satisfied, this hydrogen is also satisfied with the 2 electron system. Similarly, this nitrogen is also to be satisfied with 8 electron system. It will only 2, 4, 6 even. Remaining is now you just round up here. This is the structure of ammonia according to Lewis structure. Means hydrogen ಮಾತ್ರ 2 electron ಅನ್ನು satisfy ಮಾಡುತ್ತೆ except hydrogen the remaining atom satisfies 8 electron system. Okay na? So ಈ ತರ ಬರೆಯೋದನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ ಇದೆ. ಕಾರ್ಬನ್ ಗೆ ಏನು ಅಂತ ಆಗ್ತಾ ಇದೆ 2 bonds 4 bonds ಆಗಿದೆ ಅಂತ ಈ ತರ. And I know you can easily write this type of structure. So ಏನು ಮಾಡಬೇಕು ಈ ತರ ಬರ್ಕೊಂಡಿರೋದನ್ನ ಬಾಂಡ್ ಅನ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. In the place of bond, just represent the bond in a 2-dimensional structure. Bond and just electron in the represent. Satisfy this hydrogen emission. Satisfy the 2 electron system means double. Next, including this bonded electron. Here 2, 4, 6, 8. With the carbon is 8 electron system. So let's remember here only 2, 4, 6 is there. To maintain 8 electron system, we add 1 pair of electrons here. Here extra electron add ಮಾಡಿದ್ದೀವಿ. ಇಲ್ಲಿ 2, 4, 6, 8 ಇದೆ. So no need to add an extra electron. Next thing is hydrogen, oxygen. So oxygen is like this. Hydrogen is like this, hydrogen. This is the structure of water. So these bonds are, instead of line, they are represented in electrons. Okay, so this hydrogen is satisfied. 2. Okay, next, if you round up for oxygen, how many electrons here? 2, 4. But ನಮಗೆ ಬೇಕಾಗಿರೋದು ಎಷ್ಟು 8. 8 ಇಂದ ಎಷ್ಟು ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಡ್ ಮಾಡಬೇಕಂದ್ರೆ 4 ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 1 2 3 4. Okay, so this is structure of water according to Lewis structure. No matter whether you need to add an electron or to remove an electron, remember that must be with a stable compound. Understood? And if oxygen is valency is 6 here. Like this. This is the valency of oxygen. So if it is bonded with any atom, or this oxygen may have the capacity to form only 2 bonds. So of course here it will form 1 bond. Here another hydrogen it will form 1 bond. Even you do the formation of the bond also, you will get the same structure. Okay. So next one is NF2. So nitrogen is here. So this nitrogen, chlorine is formed. Okay. So this is represented by -. And remember, we cannot mark up this chlorine like this. This is wrong. Why? Because this chlorine is not hydrogen. It is other than hydrogen. This atom also should satisfy 8 electron system. Means if you round up for chlorine like this, ನಮಗೆ only 2 electrons there. Remaining is 3, 4, 5, 6, 7, 8. Here also 2 are there. 3, 4, 5, 6, 7, 8. Here is 2, 3, 4, 5, 6, 7, 8. 8 electron system satisfied. So the next one is when the bonded electron of this chlorine atom. So here 2 4 6 is 3. So this is also satisfying 8 electron system. That is the structure of NO3. Are you getting? So this is how we need to write the structure of atoms. If hydrogen is there, that satisfies 2 electron system called as doublet. Except hydrogen, each and every atom should satisfy 8 electron system. This is all about the structures involving single bond, double bond, and triple bond. Okay. So the next one is, in this we can easily say the bond pairs and lone pairs. So students listen here. The one which is present in bonding. So if we represent this, it will be like this. Okay, this one like this. Okay, so students, these electrons are called as bond pair electrons, and these electrons are called as lone pair electrons. Okay, what is lone pair and bond pair means? Bond pair electron means the electrons involved in bond formation are called as bond pair electrons. What is lone pair? Unshared electron of an atom. Or in the right, the electrons which are not involved in bonding are called as lone pair electrons. Here listen, in nitrogen, 3 bond pairs are there because 3 bonds are there, 1 lone pair is there. Here, 1, 2, 3, 4. 4 bond pairs are there, 0 lone pair. There is no lone pair extra electron here. Here, 2 bonds are there. So 2 bond pair is there, 2 lone pair is there. These are the 2 lone pairs. 2 electrons is considered as 1 pair. Okay, don't count here 4 electrons are there, ma'am. Why you are taking only 2? Because I am telling pair. Bond pair, lone pair. Pair means it is of 2. Okay, so here 2 bond pairs and 2 lone pairs. Here 3 bond pairs, 1 lone pair. Okay, so total bond pair means the electrons involving in bond formation. Total lone pairs means the unshared electron present in an atom. Here, these are unshared. Of course, they are present with oxygen, but they are not bonded between or shared between any other atom. They are associated with oxygen only. So, 2 lone pairs. Like. So, this is all about the structures of some compounds based on this Lewis concept. So the next one is limitations of Lewis concept. Why these structures nowadays we are not using? Okay. Why the further theories are developed? So that is what? Limitations. Okay. So say here. So students, before going to that, I'll explain formal charging. This is also important one for 1 mark or for 3 mark also they may use formal charge. Okay. So what is that formal charge? I'll explain. So initially take the formula here. Formal charge is equal to number of valence electron of an atom number of valence electron of an atom minus number of lone pair electrons on an atom, not lone pair electrons, total electrons on an atom minus half into number of bond pair electrons of an atom. This is the formula. Means formal charge, one which will get the plus charge, one which will get the minus charge. So how to find the formal charge here? So I will take the example ozone here. Okay, so listen, ozone means O3 molecule, one oxygen molecule is further bonded to two oxygen. So the structure is like this. Okay, listen. So this is all about the structure of ozone. This can also be written as like ozone structure can also be written as like this. These are called as resonance structures. Okay, resonance structures. So students here, I'll consider this one as a structure 1. This one is structure 2. So this is oxygen atom 1, oxygen atom 2, oxygen atom 3. Remember. So if the atoms are like this, then we need to assign a formal charge for them. This is the formula for formal charge. So I consider this one molecule. Okay. So here formal charge of oxygen 1 atom. Here formal charge of oxygen 1 atom. According to formula, number of valence electron of an atom. So total number of valence electron on oxygen is 6. If carbon it is 4. If nitrogen it is 5. If halogens it is 7. Understood? So for oxygen it is 6. For noble gases it is 8. The valence electron means outermost electron. You need to remember that. Often I cannot say, often you cannot write that what is it? Electronic configuration. Remember 13th group elements, valence electron is 3. 14th group, valence electron 4. 15th group, valence electron 5. 16th group, valence electron 6. 17th group, valence electron 7. 18th group, valence electron 8. Valence electrons means the number of electrons. You may take here the second group, valence electron 2. First group, valence electron 1. Nothing but lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, helium, helium. Okay, these are the valence electrons, means number of electrons in the outermost shell. So here you need to find out. So you need to remember this. Carbon belongs to 14th group, then the valence is 4. Sulfur belongs to oxygen family, valence is 6. Like that, you need to remember, you need to practice, you need to memorize. I cannot repeat. Of course, I can remember, but if I explain, you won't understand. ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಬರೋದಿಲ್ಲ, ನೀವೇ ತಿಳ್ಕೊಬೇಕು. ಅದನ್ನೆಲ್ಲ ನೆನಪಿಟ್ಕೋಬೇಕು. So formal charge of oxygen 1, according to this formula, number of valence electron of an atom is 6 minus number of lone pair electrons. Here, ಈ ಆಕ್ಸಿಜನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಎರಡು ಲೋನ್ ಪೇರ್ ಇದೆ. One lone pair means unshared electrons. So total electrons ಎಷ್ಟಿದೆ? 1, 2, 3, 4. That is 4 minus half into this one number of bond pair electrons. ಇಲ್ಲಿ ನೋಡಿ ಎಷ್ಟು ಬಾಂಡ್ ಇದೆ ಇಲ್ಲಿ? 2 bonds ಇದೆ. 2 bonds form ಆಗಿದೆ ಅಂದ್ರೆ each bond having 2 electrons to form a bond ಅಲ್ಲಿ 2 4 ಒಂದು ಬಾಂಡ್ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕು. So this is 4. So now it is 6 minus 4 minus 2. So that is 6 minus 6, that is equal to 0. And just say, and directly write here 0. Okay, next you consider formal charge of oxygen 2. Same, oxygen 2, this one. Okay, here of course according to this formula, number of valence electron is 6. Okay, here are you getting? Number of unshared electron is only 2. Means lone pair electron is only 2 minus half into bonded electrons. Here 3 bonds are there. 1, 2, 3 means 6 bonds. Means 6 electrons. 3 bonds means 6 electrons. Then it is 6 minus 2 minus 3. That is 6 minus 5 plus 1. So the formal charge on this oxygen atom is plus 1. Next, so formal charge of oxygen 3. So the number of valence electron is fixed, that is fixed. Next, number of lone pair electrons. Here 1, 2, 3 lone pairs are there. 3 lone pairs means count the electrons 1, 2, 3, 4, 5, 6. Here it is 6 minus half into only one bond is there. One bond is there means only 2 electrons. So that is 6 minus 6 minus 1. The formal charge is minus 1. So here on the oxygen atom of 3, the formal charge is minus 1. This is how to assign the respective formal charge for the atoms. If it is having a resonating structure, you may consider here listen. So I consider again this one is 1, 2, 3. That may be different. Here the number of valence electrons are 6 and directly write number of lone pair electrons are 6 minus half into bonded is 2. So that is minus 1. For 2, number of valence electron is 0 means this will get minus 1. So number of lone pair electrons are only 2 minus half into bonded means 1, 2, 3, that is 6. So this is 6 minus 5 means plus 1. Here oxygen atom 3, number of valence electron 6, lone pair electrons here is 2, bond 4, the bonded electron is 4, so you will get 0. Here it is plus 1, here it is 0. This is how to find out the charge on an atom. Not only this, some other is there. I will give the example. Okay, O3 molecule I give. This is important for 3 marks. Explain assign the formal charge for ozone molecule. Okay, so the next one is okay. SO4 2 minus. Remember that. So sulfur is here. I'll just write one structure. Oxygen atom, this one, this one. This is the structure. We know only SO4 2 minus, but we don't know which oxygen getting plus charge, which oxygen getting minus charge, which one is getting zero charge. So I named this carbon as 1, sorry, oxygen as 1 and 2. Remember, these two and these two are similar. 1, 2, 1, 2, 3, 4. Remember. So I consider the formal charge for oxygen atom 1. So for oxygen, number of valence electrons are 6. Number of lone pair electrons here is 2 pair means 4 electrons minus half into bonded. Here 2 bonds are there means 4 electrons. That is 6 minus 4 minus 2, that is 0. So students, the net charge on this is 0. Here is also 0 because these two are same. Nothing is different. Next to consider formal charge of O3 molecule. O3 means not ozone, it is third oxygen. O3 molecule. Here, so the number of valence electron according to that is 6 for this. Next, minus number of lone pair electrons. Here, 1, 2, 3, 4, 5, 6. Okay, minus half into number of bonded electrons 2. So that is like this, 6 minus 6 minus 1, charge is minus 1. So here the net charge is minus 1. So this is, these two are similar. So here also minus 1. That's why this molecule is SO4 2 minus. Even though 4 oxygen atoms are there, only on the 2 oxygen atom minus charge is there. SO4 2 minus. This is how to assign a formal charge for an atom. Similarly, we do it yourself for NO3 atom. So listen, I will write the structure. N double bond O, double bond O, single bond. Just assign formal charge for the 1, 2, 3 oxygen atom. So in tomorrow's class, I will explain the structure and I will also explain the limitations of this Lewis constant. Thank you.